And thank you everybody for having us here to present to you today on the Risk Analysis Unit project on cannabis processing and extraction. My name is Kimiko and my colleague is Lucy Guo. We'll start off with just going through an agenda quickly. Today, Lucy will start by introducing you to WorkSafeBC, the Risk Analysis Unit Department, and the Cannabis Project and team. Lucy will then go over a cannabis overview, which is some basic terminology and understanding of cannabis and its overlapping jurisdictions. And then I will continue on with the cannabis processing and extraction and going through an overview of the processing, which includes the basics of extraction and processing, the hazards, risks, and controls, industry challenges so that we can close gaps by preventing injury and illness, and then what resources are available. Hopefully we have some time to have some open discussions. So looking forward to it. Thank you very much. And I'll pass it over to Lucy. Lucy, just the mic.
Sorry. Hello, everyone. Welcome to the seminar. We appreciate your time and interest. First, I will talk about section 1, which is WorkSafeBC and Risk Analysis Unit. This will be a brief introduction. Let's start with a poll question. What services does WorkSafeBC provide?
Sorry about this. I'm having difficulty to start.
And if you would like to know more about the services that WorkSafeBC provides for the employers and workers in BC, please visit this link on the page.
We may have to actually skip the poll, if you don't mind, this first poll, if you don't mind. Going
okay.
in.
Okay, thank you. Thank you for your participation. The answer is D. WorkSafeBC provide all these services. For more information, please visit this link on worksafebc.com. Thank you. Next is a brief introduction about WorkSafe, and this is WorkSafeBC's mandate, the vision, and the mission. WorkSafeBC is a provincial agency dedicated to promoting safe and healthy workplaces, and WorkSafeBC is honored to serve 2.3 million workers and 255,000 registered employers in BC. WorkSafeBC collaborates with employers and workers to save lives and prevent work-related injuries and disease, and also help employers and workers comply with the Workers' Compensation Act and the Occupational Health and Safety Regulation. WorkSafeBC services include education, prevention, compensation, and support for injured workers, and no-fault insurance to protect both employers and workers. Next is an overview about Risk Analysis Unit. So this RU is a department within WorkSafeBC's Prevention Service Division, and this is our mission and the mandate. RU looks for risks that employers may be unaware of or risks that may be difficult to control by reviewing and analyzing both internal and external data sources to identify hazards and assess related risks to workers in BC. The RU's mission is to support WorkSafeBC's mandate by identifying and analyzing risks before harm occurs, and then determine the best approach to reduce those risks. RU's mandate focuses on 4 categories of risks. The first one, emerging risks, are new or unknown to us. For example, this cannabis project was initiated due to the federal legislation change to legalize cannabis in October 2018. Another example is a project on hazards related to electric vehicles. The catastrophic risks have the potential for serious injuries, fatalities, or extensive damage to properties or equipment, such as fire or explosion. Slow-acting harms have a long latency period between the initial onset of exposure to the manifestation of adverse health effects, such as occupational disease, asbestosis, or silicosis. The last one, invisible risks, are not fully revealed and may be hard to detect, such as Legionnaire's disease. For more information, please visit this link on WorkSafeBC.com. Thank you. Next, the RU Cannabis project. In October 2018, the Federal Cannabis Act and cannabis regulations came into force to legalize cannabis, and this change in legislation led to a subsequent rapid expansion of the cannabis industry. In order to identify the hazards, assess risks, and identify controls for risk reduction in this emerging industry, RU initiated a project on cannabis cultivation. In October 2019, the Federal Cannabis Act and cannabis regulations were amended to include edible cannabis, cannabis extract, and cannabis topicals, which can be lawfully produced and sold in Canada. This change in legislation led to a new type of business operation, which is cannabis processing to extract desired substance from cannabis plants. The cannabis industry was booming again because more employers started joining this industry. Some employers started to modify their facilities to carry out cannabis processing in addition to their existing operation of cannabis cultivation, while other employers switched from cultivation to processing only. Even equipment manufacturers started to produce extraction equipment specifically designed for cannabis plants. By comparison, the cannabis cultivation is a business operation that falls into the agriculture industry and involve hazards such as pesticides, fertilizers, biological hazards, carbon dioxide enrichment, electrical systems, and UV lighting and radiation. Cannabis processing is a business operation that falls into the manufacturing industry and involves distinctively different hazards from cannabis cultivation, such as flammable solvents that can cause fire, pressure vessels that can cause explosion, and chemicals that can cause toxicity and asphyxiation. Cannabis processing has the potential for catastrophic risk outcomes than cannabis cultivation. Many instances related to cannabis processing have been reported around the world that led to serious injuries, fatalities, and extensive damage to properties and equipment. The cannabis projects also led to the creation of a new classification unit called Cannabis Cultivation, Processing, and Product Manufacture, which became effective in 2021. Project team, industry, and collaboration. Here is the project team and the internal and external stakeholders. The two projects were complex and involved a full project team and partnership and collaboration with many stakeholders, both internal and external. Kimiko and I are both grateful to work with a group of highly knowledgeable and experienced professionals toward the common goal of risk reduction. And we want to thank them for their time, effort, expertise, contribution, dedication, and perseverance toward this project. That's section 1. And now let's look at section 2, cannabis overview. Cannabis 101. Let's start with the second poll question. Thank you. What are the desired substances extracted from cannabis plants? Thank you for your participation. The answer is C and D both, CBD and THC. I will talk about this in details later. So what is cannabis? The Federal Cannabis Act gives a definition, and this is the cannabis. And so cannabis plant or anything referred to in Schedule 1, but not in Schedule 2. What does this mean? So using the process of elimination, we know cannabis is not a seed, not a stalk, not a fiber, and not root. So everything else left is called cannabis. Cannabis overview. Please note that because this cannabis project started in 2019, some information shown here was gathered through literature research and review from 3 years ago and may be out of date. For most recent information, please refer to reputable resources. To understand cannabis better, let's look at two terms, terpene and cannabinoid, which are both chemicals compounds produced by the cannabis plants. Terpene are chemicals that determine how things smell. They give fruits, vegetables, flowers, herbs their signature scents, such as orange smell citrusy or pine trees have that unique aroma. Currently, there are more than 20,000 types of terpenes in nature, and more than 100 terpenes are unique to cannabis plants. On the other hand, cannabinoids are chemicals that can affect both the body and the brain. More than 100 cannabinoids have been identified in cannabis plants. Here are the most 6 common terpenes that are present in higher concentration, and each one has its own distinctive smell. And here are the 2 most common cannabinoids, THC and CBD, that are present in higher concentration. Both terpenes and cannabinoids are produced by these tiny hair-like trichomes on the cannabis flowers. So imagine these trichomes like factories. When they are exposed to UV lights, trichomes will produce more terpenes and cannabinoids, which increase their concentration. That's why the industry use the UV light to stress these plants to produce more terpenes and cannabinoids. Next, let's look at cannabinoids, THC and CBD, which are the most common and the most well-researched. Here are their full names. And THC has both psychoactive and therapeutic effects. CBD only has therapeutic effects. Both CBD and THC have the same chemical structure, and that's their chemical formula. But they look almost identical, except this part, which makes a big difference in the effects on human. So that's cannabinoids. Let's look at regulatory structure. Here is a summary of the regulatory structure related to cannabis, which is complex and involves various jurisdictions and agencies. Each has their own regulatory requirements and different focus, such as license or permit, workers' health and safety, technical equipment, and public safety from different jurisdictions. Next, Kimiko will walk you through the cannabis processing and extraction project. Thank you, Kimiko.
Thank you, Lucy. And I'm just going to load up my screen here, but I bet you a lot of you didn't think that we'd be going through an organic chemistry lesson, but you'll see that there is a lot to cannabis processing and extraction. And let's start out with some basics here and weed out some of our findings. So yes, everybody's supposed to laugh there. So I'm just going to check. Can everybody see my screen all right? I would assume that we're all good. Okay, thank you. Appreciate that. So the project learning overview, cannabis being new to the legal recreational back in 2018, there was a lot unknown to WorkSafeBC. In anticipation of a large market and demand, there was an initial surge of and growth in the sector. So there was a lot of new employers and a lot of new workers. It was very interesting, and part of my part of this project is to go and do site visits and do the inspections with the employers, looking at worker health and safety. So it was really interesting to see the wide range of business plans and setups. You could see how they operated, who they hired, the various differences that they had. But as producers were understanding the market demands, their marketing strategies also needed to change within the environment, and everything was really competitive. So you would see that a lot of new products were being developed. Premises were changing from cultivation, so changing their cultivation rooms and turning them into extraction rooms. So there was a huge dynamic change in the market. These processing facilities are very much like large-scale laboratories. The equipment is complex and very expensive. There's a vast amount of different products, and each of their products have their own recipes. These processes that they use require large volumes of solvents and can use pressure vessels that can be up to 7,000 psi, so huge pressures. The potential risks that we saw could be catastrophic, and it fit quite well into our risk analysis unit for a project. So in the cannabis industry, having a processing license from Health Canada allows you to process cannabis. It doesn't allow you to grow cannabis. That would require a different license. So we're looking here with the second phase, and it starts with 4 basic phases to cannabis processing. And that's not including any packaging or janitorial or their research and development. So it starts with storage of the products, such as the dried cannabis or solvents. Then any preparation that is done to that material. I'm going to turn on here. Sorry. So the preparation here is the second. We'll go into a little detail the last 3. And I'm just going to ask everybody if you wouldn't mind just checking your microphones just so that other people can hear. Thank you. So preparation, that will include destemming, drying, sorting of the cannabis, and often there will be what the industry calls particle size reduction, which is a fancy way of saying grinding. The cannabis may be heated in ovens or to undergo decarboxylation, or even flash frozen with liquid nitrogen. And so these pictures here, this is a picture of an oven that may be used, and this is used in a refinement here, but it can also be used in preparation, so of the dried cannabis, heating it up. This would be a grinder and a sorting area. So what is extraction? It's a very small but important process of the cannabis processing. It uses different techniques to remove the desired components, and that may be the terpenes, it could be the cannabinoids, or even other parts of the plant material. The naming of the product is usually named after the process. So like rosin is a product, but the process that is used is also called rosin. So products made from extraction are usually in the 10 to 60% for your terpenes, crude oil, or resins. And we'll go on to a poll question here. And if you could name some, and this is a tricky question, name some of the products produced by extraction. I think people, initially people like the names of the pink kush and purple haze. We got some experts in the audience, I see. So I think that we can end the poll and share the results. So it was a bit of a tricky question there. The answer is, the answer here is B, rosin, the butane honey oil, and the crude extract. And you can see in the pictures here, this is exactly what they look like. The rosin, that's actually made from using heat and pressure. And we'll go into a little bit how that's categorized. The butane honey oil and the CO2 crude extract. That's all an extraction process. The shatter and concentrates and dabbables would be made from after your refinement. Your extraction overview, so it's divided into two main groups, your solvent-based methods and your solvent-less methods. So your solvent-less methods are using those manual or temperature and heat to extract the products that you want. The industry does consider, although those in chemistry would know that water is a solvent, but the industry considers water as an extraction-less method. So you can see here your manual sift extraction that would make products such as keef, your water extraction like bubble hash, your pressure and heat extraction, that would be your rosin. And then the second method is your solvent-based methods. And we can further divide that into two major categories, your non-pressurized alcohol extraction and a pressurized solvent extraction. Your non-pressurized alcohol, again, it may use a low vacuum, but it's not going to be using the pressure vessels. In the pressurized solvent extraction, you have your hydrocarbon extraction and your carbon dioxide extraction, which are your two most common. There are other types of extraction, but we're only going to mention the most common ones that you would see out in industry. So when you see an extraction room, they can, the extraction equipment can be large, like the one that you see on the left here, that it goes right up to the ceiling and takes up a fairly large room, or it can be smaller, like the one on the right, which is probably about the size of myself, and I'm not that tall, but it is, you can see this one here is on rollers, so it can move around the room, which brings its own complications on potential risk to the workers. So let's go on to the fourth phase, which is the refinement, which is exactly what it means. It is purifying or separating out the crude extractment to further purify. There can be one or many stages of refinement, and it all depends on the end product that you're trying to produce. This first column here, you're going to have your secondary derivatives that are going to be in your 40 to 75% concentrations, and it's using methods such as winterization, filtration, evaporation, crystallization, or vacuum treatment. Let's say, for example, CO2 extraction, because of the CO2, you have a lot of fats that are pulled out during the extraction. You'll often see that they're going to do a winterized process afterwards, afterwards to pull out those fats. Then you have tertiary derivatives. Again, you're purifying it, so you get the 70 to 95% range, and it's using methods like distillation and decarboxylation. And then finally, you can have separation and recombination that your highest percentage where you're getting around the 95 to 99% range. And you can take those individual components and then recombine them to make your desired product that you want for retail. What you'll see with refinement is that it has very similar hazards as extraction. And this is the type of equipment that you'll see in refinement. This first one here is your molecular distillation. This one right here is some reactor equipment for the for isolates or crystallization. And then this is your rotovap. This is a falling film evaporator and winterization unit on the top there. So much like you would see in a lot of your chemistry labs. So let's go on to the hazards, risks, and controls. So there are 6 main hazards that were within scope of the risk analysis unit project. And if you remember way back when Lucy was speaking, those are the hazards that are emerging, catastrophic, invisible, or can cause slow acting harm. There is a lot more hazards there than just these ones that are listed, but these are the ones that our department focuses on. So these hazards are in the second column here, and depending on the products made, all to none of the hazards could be present at a facility. And these last 4 columns are divided into where you would see the hazards in those 4 stages that we divided the processing up into. So we'll start with CO2. It's typically will be used in the as a solvent for extraction, but you'll see here, you can see it as a risk in storage as well as refinement. In cryogenics, which can cause asphyxiation, you can see this hazard in all 4 phases. For ethanol, that can cause fire, explosion, or intoxication. And that is used as a solvent during cannabis extraction, but can also be used in refinement. So for example, the winterization uses an ethanol. Then you have the plant particulate, and that's going to be mainly in your preparation. There is a risk during the extraction when you're loading as well as unloading the material, but it is far less. And the major concern would be through the grinding machines. Then we have during extraction, the pressurized systems, so potential for an explosion. And you'll see that in not only extraction, but in their storage. They'll have micro bulk or bulk tank storages for your CO2 or for your hydrocarbons. And then also with potentially with some of the refinement activities, we'll have pressurized systems. And last here are your propane and butane, and it's a potential for fire and explosion. And you can see that that will be your extraction, but also a risk for refinement as that you can have off-gassing of the propane and butane during the refinement. And I want to show this video. It's really short, and we might have to play it a couple times so everybody can see it. But what you'll see is that this is an extraction room, and 2 fellows here are working on some product, and I believe it's butane honey oil, and that they're making shatter. So we'll play this. One moment. Here we go. So really, really fast what happened there. You can see that there's a bunch of things that went wrong, which we'll talk about in a little bit. But let's take a look at this poll. What went wrong in the clip of the incident? So we'll wait for the poll to come up. See what everybody says. I didn't wear hairspray today, so I think we're all good. Okay, well, I think everybody.
We should let it go for just a little bit longer. It's quite a complex poll.
Yeah.
Okay, it looks like it's settled out.
Okay. So yeah, we've got most 49% with the last. You see that some people picked B, which is ignition source, which is true, but the majority is right. B, C, D, E, and F is right. And let's go back and play that video again, so that you can see what we're looking at. So it happens really fast, but you'll see that this person is using, it looks what to be a heat gun to heat up the butane honey oil to make, to get that off gassing of the butane to make shatter. Oh, it's not playing, sorry. So he's using a heat gun, heating it up, and then that person opens the door and boom, really fast. He gets actually stuck in this room and can't get out because the fireball's in the way, and he can't get out that back door. And then you have the equipment, which makes matters even worse. The equipment's not stable. So when this all happens, the equipment falls over, which is filled with solvents, flammables, which falls and releases even more. So a lot of, it's a whole myriad of problems there. Okay, so that's why it's important. Oh, too far. That's why it's important to assess the system. Cannabis processing and extraction is very complex with many interactions. And if they're not looked as a whole, failures can be missed. Factors that you're going to want to consider are the processing procedures, the chemical hazard properties, including the quantities and location, the facility design, the equipment design, and how the workers are interacting the equipment. So every one of these slices of pie really had, you could have a role to play in that incident that occurred in that clip. So before we go into some controls, let's do a last poll here on what kind of controls, engineering controls, would you expect to see in a processing facility. Some things that you might want to see and in that incident that occurred, possibly. Some that may not pertain to that particular equipment as well. All right. I think we're good. And we'll share the results here. A, B, and C, absolutely. Those are engineering controls. So Lucy did this question. She made it tricky. Safe work procedures, inspection and maintenance, and personal protective equipment are not engineering controls. Those are the first three would be your engineering controls. So what we learned in this project is that there are, depending on what you're making, what you're using, what your facility is set up as, your controls would need to be specific for your what you're doing. What we have here are two charts here. One on the left are control examples for extraction equipment, and the one on the right is control examples for the facility design. The two columns that you see, let me get my laser pointer here. The two columns that you see in both of them, the first column is going to be for your alcohol extraction that is in a system that's not pressurized. And then your second column here is your pressurized system, regardless whether it's flammable like your butane or propane or your CO2, which is not. So these are some controls that you may see, like the electrical needs to meet the hazardous area standards, the local exhaust ventilation or general ventilation and emergency ventilation. All of those are different and need to be considered. Monitors and alarm systems tied into your ventilation systems. Fire suppression and containment, wouldn't that be great in that incident that occurred? I think that that person would have been able to get out of that room without being seriously hurt. Emergency shutdown of the rooms. So when things like that happen, then it's not going to go beyond that room. And then emergency washing facilities and safeguarding and lockout are just some of the considerations. But I want to go into specific on some controls. Bleed bolts, for example, are safety features that are designed on equipment to warn the operator that when they're opening it, that the system is pressurized. This would have prevented some catastrophic releases that occurred here in BC. Some facilities use this equipment and didn't use filter bags, for example, in the equipment. So if you can imagine this extract, it's gooey or can be gooey, and it can clog up the system and clog up the gauges. So the operators thought that they were opening a system that was no longer pressurized because the gauge read 0. If they had a bleed bolt, it would have hissed at them to let them know that, hey, this is actually still pressurized. Bleed bolts are an important control that can be used. Also, I want to say that pressure vessels require to be certified and have a Canadian certified number. And here in BC, Technical Safety BC is the one that does the registration for pressure vessels. And so they all need to be registered with Technical Safety BC and have a placard on them that has a stamp that has the CRN number and something equivalent to the ASME, have an ASME stamp or equivalent. The second control that I want to just mention is pressure relief valves or safety relief devices. And these are a control in themselves to prevent rupture of the pressure vessels. But then you also have to look at where they're placed on the system. So yes, these prevent a catastrophic event of rupturing of the vessel, but if they're releasing in the general area inside the building, then you're creating a different hazard. So the design of where these release out to have to be a safe location, and preferably outside of the building. And industry challenges is our next area. The industry faces a lot of challenges. One, that it's a very complex legal framework. There are multiple regulatory agencies with specific areas of focus, and all having their areas that they want the cannabis employers to be aware of. So you've got Health Canada, you've got the government of BC, you have WorkSafeBC, you have Technical Safety BC, the Office of the Fire Commissioner, and local municipalities. So they're very overwhelmed. They have a lot, being a new industry, a lot of jurisdictions that are trying to learn about their industry, and also letting them know what their requirements are. So it is a lot of different jurisdictions going in and trying to that take up their time. The second is that the license application is a very lengthy process. And we found that a lot of operators were already in operation, even though that they haven't received their approval from Health Canada, but they have workers, and they're so busy trying to get their license, because it's if they don't get their license, then everything is off the board. So their focus is that Health Canada license, that it's just an oversight sometimes for other jurisdictions like WorkSafeBC. Often employers were not aware of standards and controls, and even the manufacturers were not aware of standards. And there's many reasons for that. Some of the standards, and I'll show you, are relatively new, and that could be the reason, or that just a lack of understanding of what BC requirements are. Often there was a lack of understanding of controls. Even when employers reached out for help, they also didn't get the answers that they were looking for, because there was just such a dramatic change in the industry, and they couldn't get the information that they were looking for from the different jurisdictions. And the manufacturers didn't know what the jurisdictional requirements were, and all around the world, they're all around the world. So some are from the States, some of them are from across the seas, and the jurisdictional requirements in Canada, especially for pressure vessels, are specific here. And if they're getting their product or getting their equipment from a manufacturer that is not able to provide them the support, local support and local expertise, then we found that a lot of employers were running into some problems. And when employers had reached out for engineering expertise, they also ran into problems, some costly mishaps. Some of them weren't able to find an engineer that had the expertise, or they hired an engineer, and that engineer didn't had to hire somebody else for a particular area. And so there was a lot of setbacks within the industry. And so our last section here is some of the resources, and I think that these are really important to share with everybody. First of all, this is two of the standards specific for cannabis here in BC. And if you notice the dates on these, this is 2019 for the 4400 and 2020 for the 1389 that has to do with the extraction equipment. So both relatively new. So a lot of facilities didn't know about them, didn't know that they needed to meet these. The next is the NFPA. There's NFPA 1, which there's the section in there that has specifics for cannabis. But NFPA is also coming out with NFPA 420. And no, that's not a joke. I think the firefighters have a great sense of humor. So they decided to call it 420. And it's on the standard of fire protection of cannabis growing and processing facilities. It's not out yet, but it is going to be out soon. And then there's also NFPA 36 as well for the solvent extraction plants. And then can't leave without saying that WorkSafeBC has resources. Just like Lucy had said, we started with the cannabis cultivation. So there is a health and safety resource for cannabis cultivators here on the right. And then just out, actually this October, it's out now and is online, is the Cannabis Extraction and Processing Risk Advisory for Pressure Vessels. So you can click on this link. I don't even think everybody on our team has seen the live one yet. So you guys are the first ones. So that is now available. And we're also going to be releasing fairly soon something similar to the health and safety in cannabis cultivation, but it's going to be on extraction and processing for employers. And then they did a article for Ask an Officer on managing risks, and that is also online. And I will open it up to everybody. Thank you so much. I really enjoyed presenting this, and I hope that you enjoyed it as well. I'm looking forward to any questions that you may have.